Hello, in this video I'll be configuring the LCD display on the FPGA board. To start, I'm going to create a new project in Quartus. So I'll go to File, New Project Wizard. Next, for the project directory, I will be selecting a folder that I've created in my desktop that is called LCD Controller. I'll select that folder, and then for the project name, I'll type LCD Controller. Click Next. In my LCD Controller folder, I already have a file, a VHDL file named LCD Controller that displays default or default text on the display. I'll select that file, click Open, and then Add. Next. For the device family, since I will be using the DE2-70 board, I'll select Cyclone 2, and then under or next to the name filter, I'll type the device name. I will select it from here, then I will click Finish. The LCD controller.vhd file that I have displays default text in line 1 and line 2 of the display. Before we modify the code, let's look into the LCD display and how it works. So basically, the LCD display that is on the board has 2 rows and 16 columns. So this means it can allow us to provide text within 2 separate lines, and then up to 16 characters per line. To decide on what data to be displayed, what data is displayed on the screen, we'll need to look up the ASCII table to find the ASCII representation of each character that we want to print on the screen. So here I created a 2 row by 16 column table, in which I'm gonna be typing the ASCII representation of each character that I want to display on the screen. So assume I want to display my name, AMAL, in the middle of the first row and keep the second row empty, or the second line empty. Then to start, in the middle of the first row, I'll be finding or typing the representation of character A in ASCII using hexadecimal values. For uppercase A, for example, the hexadecimal value is 41. So here we need to say 41. And then for the second character in my name, I need the lowercase m. M is 6D in hexadecimal. And then lowercase a is 61. For lowercase l, it's 6C. The remaining cells in my table, I'm going to be filling them out with spaces. So for the space, we need to say 20. So for the space character, it's 20 in hexadecimal. So all the values in the table will be 20, except for the middle of the first line, where we have 4 different characters different from 20. Now I will be copying these values, and remember that the space is 20 in hexadecimal. I will paste the values in my Quartus project as a comment to use them for line 1. In the code that I have, line 1 represents the first row in the display and the characters that are displayed on it. And line 2, of course, is for the second row in the display. Before I provide the values for line 1, assume I want to erase the bottom line fully. So I'll be replacing each character with the ASCII representation of a space, which is 20. 20 in hexadecimal, so x20. Here and that's it. And for the first line, line 1, I'm gonna skip 6 characters, so I'll start with 6 spaces, 20, 20, 20, and then 3 more. And then for character A, I need to provide the value 41 in hexadecimal, and then 6D for letter M, lowercase m, 61, 60. 61, 60. The remaining characters will be replaced with a space, so 20. And then I'll compile the file. The original or the default text that I have is welcome to EDSL lab, so I can remove that from the comment. And then here it's just empty line maybe. This is for Amal. Then I'm gonna compile my modified file. After successful compilation, we'll be taking care of the pin assignment on the FPGA board. So we'll go to Assignments, Pin Planner. And then we'll expand the pins panel. For each of the nodes or the pins, we'll be specifying the necessary location with the help of the manual of the DE2-70 board. So for the first node, I have a 50 megahertz clock. So in the manual, I can look up 50 megahertz clock, or maybe if I type 50 clock, this is for the 50 megahertz clock input. The location is pin D16. So this is for the clock. The next node is port is the LCD BLON. So LCD BLON. This is pin G3. Then we need LCD data 7. So here I'm just pressing Control F to search for the pin needed. The next pin we said was LCD data 7. So we'll just look it up, and it's B2. LCD data 6 is C3. Pin C3. And finally, for the reset, we can use a push button, for example, or a key, a switch, let's say. You can search for switch 0, AA23. Now that we've chosen the location for each pin in the pin assignment window, we can click Start I/O Assignment Analysis. Then we can go to the same pin planner window to export the pin assignments file. from the file menu, we'll select export and then press enter. We can close this window, go to assignments, choose import assignments, and then browse to find the pin assignment file, the SCD controller pin assignment file. Select that file and then click OK. Next, we're going to compile once again. And in the meantime, we can connect our FPGA board to the USB port on the computer and power it on. We will now go to the Tools menu, select Programmer, and then make sure you choose the USB blaster and that the output file is chosen or is available. If not, again, we can click Add File and select the output folder and select the SOF file. We will now click Start. And then after successful programming of the board, we can see the screen, and we'll notice that it is displaying the text we decided on.